let me just open the start. Okay, so here we can see over here that we are opening this new project over here, and I'm taking this space module, and let's name it as 3D structure, and see where it is being saved. So it is being saved into your folder over here, and select these units according to your needs. Then I'm going for open structure wizard. Okay, so in this what we can see that there are some certain predefined modules are given over here, and what you have to do, you have to provide parameters of length and width of the bay, and according to the structure means the geometry of the structure you have to provide. So we have different types of models. Predefined models are given over here. So these are truss models, and these are frame models: bay frame, grid frame, floor grid, continuous beam, cylindrical frame, reverse cylindrical structure, circular beam, and we have some surface models also, like cylindrical surface, spherical surface, cooling tower. Okay, so in this, or when you will select this, you will be prompted with the screen that will be asking you the geometrical parameters of these designs. Okay, so according to that you can provide the geometrical parameters and then create the models. So let's take this bay frame over here. Okay, so you can see over here that what it is asking the total length of the building, height of the building, and width of the building. Okay, and what are these? Basically these are number of bays along the length, means length is basically your along x-axis, and width is basically your along z-axis, and height is along y-axis over here. You can see the coordinate system that is given over here. Okay, so the number of bays along length, so the default value is 3. Suppose for I want to make 3 bays of 4 meters, and number of height, this is number of bays along height, so this is 5. So I am just taking 3-story building, so let's take the total height to be 9 and the number of bays to be 3. So floor to floor distance that is given over there would be 3 meters. Okay, then width, let's take this width as also 3 bay system. Okay, and here you can see this option along the length, that you can see you can provide the individual bay length of the structure. Okay, in x direction also, in z direction also, and in also in along the height also. So if I want to give the length over here, suppose 2 and 4, so let's take this as 6. Okay, and then press OK. So this would be 12. So our length means bay should be 2 meters, 6 meters, and 4 meters, like that. Okay, so you can calculate and see and give the input according to your design. Please switch off the mic. Okay, so you can see over here that this structure has been generated and it has certain geometry that we have provided the measures of it. Okay, so what we have to do now, we have to transfer this geometry in the STAAD. So this is basically structure wizard dialog box over here. You can see over here. Okay, and you have to, whatever you can create over here, you have to transfer it to the STAAD program. So for transferring, just you have to select this transfer model, and it will ask you to transfer or merge this prototype into STAAD.Pro. Yes, and where do you want to place it? And let's see, it's asking us the coordinates. Where do you want to place it, means the origin of that structure, where it should be placed in the global coordinate system. Okay, so let's take this origin should be placed on in the origin of this global coordinate system. So just press OK over here. So you can see over here this, the structure has been, the geometry has been generated. Okay, so like this you can create geometry in a very fast fashion, and you don't have to go by node, or you have to select member by member and then copy paste it. So according to this, like this you can create the geometry of a building pretty fast. Okay, then what we have to do is we have to assign member properties. Okay, and assign load on this structure. Okay, so first of all, what we have to do, we have to go in general tab over here, and then define some sections. So let's take beam section in x direction to be 0.45 depth, and thickness to be 0.3, add. Okay, and in z direction, let's take this to be 0.3 depth and 0.23 width of the beam. Okay, and for columns, let's take 0.3 by 0.3. Okay, that would be your edge size, 300 mm. So these are the geometry that we have created. Now what we have to do, we have to select this geometry and assign this geometry to our section to our geometry, means beam that are spanning in x direction. So what we have to do, we have to select these beams. So there is one way that you can go in these views, and then you can select this one by one. Okay, and also you can choose this option over here, select, and you can select beams parallel to x, y, or z. So it will select the beams that are parallel to x, y, or z, or you can select by other properties also, by specification, by other things. Okay, so this is how you can select the nodes or beam members. So I want to select beams parallel to x. So this is so you can see over here that all the beams in the x direction have been selected, and just you have to assign this section to the beams in x direction. Similarly, we will do for z direction beams. So just select the beams parallel to z, and then we will assign the section that we have intended. Okay, then for the columns, just select beams parallel to y direction. So all the columns have been selected, and you have to assign this. Okay, so this is how you can directly select and assign the sections very easily. Okay, and if you have different sections at on the columns at different height, so what you can do is you can select columns, means one floor, one by one, then you can assign the section over there. Okay, and use these views, different views, to select the members. Okay, so that would be very beneficial for you. Suppose if I want to select this column over here, so I just selected this top view and I have selected this column. So you can see over here this one column has been selected. Okay, then what we have to do, we have to assign support, and for that we have to create one. So we are creating this fixed support over here, add, and then Okay, okay. Hmm. Okay. So now what we have to do, we have to assign the support in the building. Okay. So just see over here, means what you have to do, you have to select the support, fix support, and then you have to assign it, and you will assign to the selected nodes. Okay. So this is how you can assign the support on the building. So you can see over here in on means at the footing of all the columns, these supports have been assigned. Okay. So now what we have to do, we have to assign loads. Okay. And for that we have dead loads and live loads, and in dead loads we have self weight of the structure and self weight of the slab, and whatever the area load that is coming on to it, and the live load means whatever the load due to the live load is coming according to the structure. Okay. So this is how our next step is to create load cases. So just what we are doing, we are creating load cases over here. So let's take this dead load, and the loading type is dead, and take live load over here, loading type live. So it is having some different types of loading, means roof live, wind, seismic. So according to that you can select the whenever you are adding the load case, you can select these types. Okay. And then I'm also defining one combination over here. So that is your 1.5 dead load plus live load. Okay. And the multiplication factor is 1.5, and the cases that it is available, that is dead load plus live load. So now it has been created. Okay, you can see over here. So whatever we will add in dead load or live load, it is being already added in the combination. It will already add in the combination, automatically add. Okay. So now what we have to do, we have to add some loads in dead load. So first is your self weight of the structure. So it will be acting in gravity direction, means negative y. So that will be added as here like this. Okay. And suppose this structure is having a wall at the periphery of the structure. Okay, means the walls are constructed on the boundary of the structure. So for that what we have to do, we have to add a member load, that is your uniform force, and what will be the value of that uniform force. Okay. So first of all you have to calculate that. You can see that the inter distance between the story is how much. This is the length is of the column is 3 meters. So for one brick thick wall, what will be the uniformly distributed load that will be acting over here? So just calculate the value. So it would be coming out to be like, suppose it is like 12.5. Okay. And it would be acting in negative direction. So just put minus over here and select this GY. So it would be acting in minus y direction. Okay. And if you are leaving these D1, D2, D3 0, so it would be when you are assigning the load onto the member, it will automatically spread on the whole span. Okay. So if your uniformly distributed load is spanning in, means at some distance or at in some interval at the member, so you can define this D1, D2, D3 according to your need. Okay. Now what we have to do, we have to assign it. So just select this and select assigned to views because the self weight of the structure will be assigned to all the members. Okay, and then what we have to assign, this member load means on the beam. Okay, so how you can assign it? First of all, what you will do, suppose if I am going to select this beam like this, so what will happen, it will also select these columns also. Okay, so either you can select like this, means you should not touch the columns. Okay, and if you are not sure, then what you can do is just select these floors by pressing control. Okay, means you can press you have to press control for selecting more than one member, and then you have to view selected objects only. Okay, so you are viewing your selected objects only. You can see over here, means I have selected only all the all the floors over here. Then what we have to do, we have to just select these periphery beams. Okay, we have to select periphery beams over here like this. So you can see over here that means all the beams have been selected on the periphery, but this masonry load will be acting on this floor only, means on the first floor and on the second floor, because this is the roof. Okay, so either parapet wall would be acting over here, or suppose there is no wall, so let's create one load for parapet wall also. Just add one load over here, that would be your half the load. So let's take like 5 kilonewton per meter, so this would be minus 5. So you have to calculate these loads according to your design. Okay, I'm taking here just for example. So first of all let's assign on the roof only. Yes, इसीलिए कहता हूँ टाइम से ज्वाइन किया करिए आप लोग. Okay, so what we have to do, we have to select the outer beams of the roof floor, then we will assign it this load 5 kilonewton per meter. So you can see over here this 5 kilonewton per meter load has been assigned. Then what we have to do, we have to select other floors, and then we will assign our wall load. Okay, so I am selecting these two floors only, and then I am assigning over here. These beams have been now selected and assigned to selected beams. Okay, and we have to assign. So you can see the intensity of these loads. You can see over here, whatever you will select, it will show it in blue. So this is 5 kilonewton per meter, and this is 12.5 kilonewton per meter. Okay, so what you have to do now, you have to add floor load also. Okay, so floor load would be acting on the roof also, and on the basically your slab load will be there. So slab will be there on roof, on this floor, second floor, and also on first floor. Okay, so if we are constructing a slab of thickness of 6 inches, or you can say 150 mm, so what would be the area load, or you can say intensity, or you can say what will be the load in kilonewton per meter square? Can anybody tell me? If the density of the concrete is 25 kilonewton per meter cube and you are providing the slab of 150 thickness, so what would be the area load? Calculate it and tell me. कितना लोड आएगा बताइए। How much it would be? 3.75. Okay, so you can see over here this floor load option is given. Okay, so in this option you can see these this is basically your ranges are given. So these are ranges that you have to provide so that it can know from where to where your load is acting. Okay, and this pressure would be acting as a load, so that would be your minus 3.75. Okay, sorry, minus 3.75. Okay, and would be acting global y direction, so it would be acting in downward direction. Okay, and you can also select this one-way distribution or two-way distribution system according to your slab system. Okay, so we generally take two-way distribution system and it will automatically transfer load according to the span ratio over here, and you have what you have to do here, you have to provide the y range. So what is y range? Means from where to where this load should be acting in this building. Okay, in y direction. So you can see over here means what you have to provide, you have to provide the length, width and thickness of the length and width and the height of the area load that you have to give over here. So our load is being acting on the whole building, means whole surface area or whole slab over here. Okay, so in this case what you can do is you can just provide the total length of the building and width of the building and height of the building. Okay, so if there is any case that you may have that on this slab there is another load of another intensity, then what you have to do, you have to provide the range according to that. Okay, so that it should not be acting on other slab. So just what we have to do is we have to see what the range is. So I'm taking this node cursor and just by double clicking over here you can see the coordinates of this node. Okay, so from 0 to 9 this y is varying, so I'm just writing over here 9. Okay, and for this value for x range, where it is varying from where to where, it is varying from 0 to 12, and for z, let's see over here this node, so it is varying from 0 to 12 also. Okay, so like this you can see if you didn't calculate it, or if you just want to see from where to where range lies, so you can see the coordinates of the node and you can calculate the total width or length of the structure. Okay, you see the total length and width, so it will automatically tell you. So what we have to do now, we have to just add over here, and you don't have to assign this load, it will be automatically assigned on the structure. Okay, because we have already provided the loading and the ranges over here. so it will be already assigned. And you can see the distribution, how this load will be distributed on the beams over here. So you can see the U-line diagram, and according to that it will be distributed on it will depend upon the length of the beam and the short span versus long span. So how it will be distributed over here. Okay. So this is how the floor load would be generated and applied. So let's add live load also. So live load will be of two types basically, that will be acting on your floors, inside floors, and one load will be acting on your roof. So on roof, according to 875, we take that minimum criteria, that is your 1.5 Newton per meter square, and just give the range according to that. So this would be acting on the roof, so that would be from 9 to 9. Okay, so remember this, because if you put 0 over here, so it will be adding this load from first floor to roof. Okay, so you have to put 9 over here. Okay, so it will be acting on the roof only. Okay, X range, but you have to provide whole from 0 to 12, and Z range also you have to provide from 0 to 12. Okay, so this, what you have to do, you have to add it. Okay. Then what we have to do, we have to provide live load for first floor and second floor, and let's take the be 3 kilonewton per meter square, and the range would be 0 to 6. Add. Okay, so you can see over here, this blue will be your roof load, and means live load on the roof, and this will be your internal loading, means live load, imposed load in the internal floors of the building. Okay, so this is how you can add these types of loads and these floor loads on the building. Okay, and then what we have to do is we will analyze this building. So first of all, we have to give the command for analysis. You have to add the command for analysis, and then we will analyze it. So just run analysis over here. Okay, done. So let's go into post processing, select our load case, and you can see over here the deflection of the beams. Okay, so you can see maximum relative displacements, where it is. Okay, and summary. So in here you can see what is the maximum deflection that would be in the structure. Okay, so this is minus 2.182 mm in vertical y direction, and it is acting at this node over here. Okay, so automatically, because this would be the load, the load will be maximum. Okay, and also you will see that on this column the foundation load will be maximum, because you can see over here this is the most loaded column in the entire structure. Okay, this and this one and this one. Okay, so that's why it is having this vertical deflection over here like that. And also what you can see over here, you can see the reactions on the nodes. So these are the reactions that you can see. So you can calculate the Fy over here, given over here. So for node 1, Fy is 185 kilonewton. So these are the values that you have to see, and according to that you have to design the foundation of the structure. Okay, so you can see over here a maximum load, Fy is coming out to be 784, and that is over here, 784 over here on this column and on this column. Okay, 741, sorry. Then what you can see over here from this post processing dialog box, you can go into beam, tab over here, and you can see the entire bending moment diagram and shear force diagrams also for this structure. So for we can see over here, so this frame is critical and also this frame is also critical, means it would be having the highest load in the entire structure. So just we can see the just select this view structure object on it, then you can easily see how the bending moment and shear force would be acting in columns and beams in this frame, interior frame. Okay, and if you want to show the values and see the values over here, and just see view value and beam results and midpoints. Okay, annotate. So you can see over here how much the load, bending moment that would be developing in the beams and columns. Okay. Also, yeah, you can see for shear also. Okay, according to that. So this is how you can analyze it, and the design part is similar to what we have already discussed. So for designing the structure, what you have to go in design tab, you have to select concrete design, IS 456, and then you have to select some parameters for the design over here. Let's take compressive strength and yield strength or main reinforcement, secondary reinforcement. Okay, define parameters we have to define. Okay, so you have to enter these values according to your material. Okay, and you have to assign some commands also. So design beam, add, design column, add, and if you are using slab elements or plate elements, you can also design those. Okay, and this is takeoff. Basically, it will give you the quantity of the concrete and reinforcement that would be used in the entire structure. Okay, so FC, that this is basically for the entire structure. So you have to assign on the whole structure, and FI main also, FI secondary also, and design beam. So for design beams, what we have to do is you have to select the beams using this beams parallel to X, and press Ctrl, select beams parallel to Z. So this is how you can select all the beams, and then press assign over here, then all the beams will be assigned this command design beam, and likewise you have to select the columns, and then you have to assign the columns. Okay, what you have to do then, you have to then reanalyze it. After reanalyzing, you can see that it has been designed for the applied load. Okay, so you can see that individual column over here. If you want to see over here that this concrete design has been approved for this column for this particular PU load and moment. Okay, so this is heavily loaded column. Let's see what concrete design is given over here. Okay, so you can see over here this load can be and also you can see the detailed report in the STAAD.Output file. Go to the results, concrete design, and you can see the beam value and the column also, column results. These are the column design. So you can see the PUZ, MUZ1 and MUI1, and according to that what is the load case, critical load case for which it has been designed, and what are the reinforcement details that you have to provide. So all things have been provided in the STAAD.Output viewer. Okay, so just go through this video. I will upload this video on Google Classroom. I will send you the link of it, and what you have to do, you have to go through that tutorial sheet and analyze that structure and compare it with the manual design and make a report Okay, according to that. So that would be your for internal assessment. Okay. So is there any question regarding this? You can ask me. Is there any step you want to ask? Then you can tell me. Just let me know.